Now, guys, I've got a very special treat for you. We're now going to go into the International Space Station Mission Control Room and speak with public affairs commentator Kylie Clem and a robotics engineer, Jonathan Rogers. Are you guys there in Mission Control?
Hello, we're here in Mission Control. Welcome. We're glad you could join us today, and we're happy to take questions. I'd like to introduce Jonathan to you first. Jonathan Rogers is a robotics engineer. He works with Robonaut 2 and other robotics here on the ground. Robonaut 2, as you mentioned, is on board the International Space Station, which is controlled from this room. The team here is watching over the systems and following along with the 6 crew members who are living and working on board. So I'd like to talk to Jonathan first about his background and how he came to work at NASA.
Well, hello. As we've said, my name is Jonathan Rogers. I actually came to NASA through an outreach program that my current group does. It was called First Robotics, and it gives an opportunity for high school students to work with professional engineers, in my case NASA engineers, to develop a robot to play a game each year. And that competition just started a couple weeks ago, so we're looking forward to that. Following participating in the First Robotics program, I went to Texas A&M University where I got a degree in aerospace engineering. And during that time, I was able to take part in NASA's cooperative education program, which allowed me to spend semesters here at the Johnson Space Center working on robots. And then I would take that knowledge and apply it to my classes. And then I've been full-time working on the Robonaut 2 project for the last 4 years.
So how's it been like sending the Robonaut to space and then working with it in space?
It's been an amazing opportunity. When we developed the project, we started in 2007. It was a partnership with the General Motors Corporation. We found out that a lot of the goals that we have match up with the goals they have in terms of helping people through the use of advanced robotics. So we began this project purely as a technology demonstration platform where we could try out new things and really push the envelope of what robotics are capable of doing. When we announced the project to the world in 2010, we were given the unique opportunity to fly it on board the International Space Station on STS-133, which was just about a year ago, last February. And in August, we began working with it, and we're continuing to check out the robot and make sure it traveled safely to space. And we really look forward to the future and finding out what it can do to help astronauts.
So what have you had to do? You worked with the Robonaut here on the Earth for quite a while before it actually went to the space station and other robots also. So now that it's on board the space station, what have you been going through to make sure that it's working well?
So to begin, we just turned on the robot and let it sit there for a couple of hours on board the space station. During that time, here in the Mission Control Center, we watched data, and we checked out all the sensors aboard the robot to make sure that they had successfully made the trip into space. And we were also learning how to interact with the crew members on board and the other flight controllers here in Mission Control to safely accomplish our goals. Over the next couple of checkout activities, we've begun moving the robot. So we exercise every single joint aboard the robot, and we learn how it's different to operate it in space than we've been working with it here on the ground for the last few years. And while it may seem very, very similar, there are some subtle differences that really change how you control a robot.
And what do you think it might be able to do in the future on board the space station?
So some of the tasks that we're really going for are things that are dull or boring for the crew that take up a lot of their time. For example, we would love to have the robot be able to clean. The crew devotes a significant portion of their time on the weekends to just cleaning up around the space station. That way it's nice and tidy, and it's a good place to live. So if we can have a robot go take care of some of those tasks and offload it from the crew, they can either have more free time or more time to spend on different science experiments.
Sounds good. Well, we'll go ahead and start with questions from the students.
Questions? What questions do you have about the man who actually was instrumental in building Robonaut? Go ahead, nice and loud.
Will you ever add legs to the Robonaut?
Yes, we're actually working on legs right now. We've got a pair of them in our lab here at the Johnson Space Center, and we're learning how to control those here on the ground before we send them to space. But the Robonaut is unique in that we can suit the lower body to the task at hand. So if we were to send Robonaut to a planet as we go and explore the solar system, we might find that like an off-roader type of vehicle might be suitable for the lower base. Climbing around on space station, we've determined that 2 legs will be the best way to get around. And that might change as we go outside the space station to help astronauts with spacewalks.
Great picture. Go ahead, Stephanie, nice and loud.
What's inside the Robonaut's helmet?
Inside Robonaut's helmet are actually 5 cameras. We've got 2 cameras that are used by a human operator. One of the modes we have to control Robonaut is where a person puts on virtual reality gear. So you wear a headset and put on gloves, and the robot will actually mimic your motions. So we have cameras in there that are used for teleoperation. And then we also have 2 more cameras that are used for machine vision. Robonaut is programmed to identify things in its environment, and we use those cameras to do that. They're really high resolution and allows the robot to see very good. And then finally, we have an infrared camera, which allows the robot to get a sense of depth in front of it.
Nice. More questions? Go ahead, Emily, nice and loud.
What's the robot powered on?
So right now, we're getting power from the International Space Station itself. We get power off the solar arrays that's passed through a number of systems before it gets to the robot. Inside the robot's backpack, we have power conversion that turns it into the different voltages that the robot needs to run. One of the things that we're working on as we develop legs is also a large battery backpack. That way it won't have to be plugged in all the time.
Go ahead, nice and loud.
How many people were needed to make a Robonaut?
So to build Robonaut, we had a team of about 25 people. So it's pretty small. But as we've gone through the process to send it to space, we've had to bring in a lot more experts. We're very good at designing robots. We don't know anything about how to prepare them for space flight. And there are experts here at the Johnson Space Center who specialize in that. Those folks work on things from making sure that we're compatible with the power system on board Space Station and making sure that we don't put out any harmful radio waves that might interfere with other experiments on Space Station. And then one of the biggest surprises we had was that we had to change the robot's suit. So the clothes that we had put on Robonaut were actually too flammable to be considered safe for Space Station, so we had to make that change as well. And we brought in the right folks from here at the Johnson Space Center to help us. Now I'd say we probably have between 75 and 100 people working on Robonaut at least part-time.
Go ahead, nice and loud.
How did you guys get the idea for Robonaut?
So the Robonaut project started in 1997 with the goal of designing a robot to help astronauts on spacewalks. As astronauts were building the International Space Station, there were many times where we identified a need for an assistant or a surrogate to go out and help astronauts do different tasks. So we've been working on the robot ever since, and this is Robonaut 2 that's on board the space station, which is our second generation.
Go ahead, nice and loud.
What materials or tools did you use to make the Robonaut?
That's a very good question. So primarily it's aluminum. In certain places we have steel where we needed a stronger material. And then we also have a lot of plastic where you didn't need as much strength in an area, but you wanted electronics or something to be protected. For example, the helmet is plastic.
Go ahead, you have a question? Anybody else? Go ahead, Em. No?
What did you add to Robonaut 2 that Robonaut 1 didn't do?
Another great question. With Robonaut 2, we concentrated on making the robot faster, stronger, and smarter. So in addition to changing the motors and things that allow the robot to move, we also added a lot more sensing. For example, the robot has sensors in each of its fingertips that allow it to feel. Um, you can think of the technology as, reaching into your pocket to tell a nickel from a dime. Um, we have different cameras on board that, like I said, have higher resolution so we can see the environment in front of the robot better. And then the control system, the software that runs the robot, is also very different. Uh, in our partnership with GM, we found out that we want robots to work very close to people. In traditional robotics on assembly lines, you have cages and a number of different things to keep robots away from people so that people don't get hurt. Um, in our view of the way robots and people should work together, they'll be very close. So we added sensing and programming to allow the robot to work safely around people. For example, it can bump into you and not hurt you.
And learn to say, excuse me.
It actually can't talk yet. That's one of the things that we haven't worked in. We need to put some speakers in, but we didn't have time to do that before we launched it to space station.
Did it go up on a separate mission, or did it go with astronauts that were going up, or did it go up by itself automatically?
It flew up as a payload on STS-133.
Right.
And there were astronauts aboard as well. It was Discovery, I believe.
Yeah, the Space Shuttle Discovery.
Go ahead. Payload means the supplies that are going up. In other words, when they say they're bringing payload, they're bringing food, they're bringing water, they're bringing machinery, tools, correct? Is that correct?
That's exactly right. So we were packaged inside a protective box and a lot of foam, along with a number of replacement supplies for space station. Since the shuttle program was coming to an end, we were launching a number of different things that'll ensure that the astronauts have what they need to continue operating space station safely.
This is a live picture here of Mission Control. Go ahead. We'll have both of you. Go ahead.
How long has the robot been up in space?
It's been there almost a year. STS-133 launched in February of 2011.
One more month will be a year. Go ahead.
What are the similarities between like the joints and things like that of the Robonaut and humans?
Another great question. So Robonaut has electric motors in each of its joints. So where you have muscles that allow your arm to move, we do it a little bit differently, but the resulting motion is still the same. The hand is more similar though. If you move your hand, you can kind of feel muscles in your forearm move as your fingers move. And in Robonaut, we have mechanical actuators that pull tendons to move the fingers, and that's exactly how the human hand is set up. There's a lot we can learn about how to build a human-shaped robot from the human body itself.
Somebody else had their hand up. Yeah, go ahead.
For travel, well, why do you need both humans and robots up when they're like the same place?
So, like I mentioned earlier, there's things that the crew has to do that takes a lot of their time that maybe doesn't require their full attention. For example, cleaning takes up a lot of their time, so we can have a robot that maybe doesn't have to be as smart as a person, but can take care of those things. A couple other ways that we anticipate using a Robonaut include being a surrogate for an astronaut. So think of a mission that might be kind of dangerous if we're exploring a planet and there's somewhere new. Maybe you don't want to send an astronaut down a cave or something that could be dangerous, but you kind of want to know what's down there. If you send a robot and something bad happens, you lose a Robonaut, but the astronauts are still okay, and that's what we really care about. Additionally, we want to use Robonaut to help set up for spacewalks. A lot of time that the astronauts use on a spacewalk, where they go outside the space station to do a maintenance activity or assemble something, is spent setting up. If you could have a robot go out there and do it ahead of time for them, they can devote more time to their task at hand.
Go ahead, sweetheart. Nice and loud.
Has it had any issues yet?
Well, we're discovering that there are differences in between how we run the robot on the ground and how it's operating in space. Um, for example, you don't have as much friction in some of the joints. That's less resistance as you try to move the robot because there's no gravity. So little things like that we're learning, and we're making adjustments as we go.
Okay, sounds good. I'll give you late passes. I think we're almost finished anyway, so.
And if you guys have any additional questions, for example, about the space station itself or mission control, I believe Kylie will be able to answer those as well.
You have any questions for the woman who's here, Miss Kylie? She can answer any questions about mission control and the people who are sitting. Did you notice the people sitting at the desks and things like that? Yeah. Do you have any questions for that group? Yeah, I think we're okay.
All right, wonderful. Well, Kylie and Jonathan, I want to thank you guys for joining us today from inside the International Space Station Flight Control Room. And boys and girls, can we give them a good round of applause?
Thank you.
Thank you so much.
Thank you.
We have one final thing we'd like to say too.
Okay.
Yeah,
You're
thanks so
welcome.
much. And thank you very much for your time. I can't tell you how informative it was. And you could tell by the questions the level of interest. And these are your future roboticists right here.
Mm-hmm.
Thank
And
you.
before we close, students, if you want to stay on the line, I want to go over one final thing with you guys. Thank you.